So hey, welcome back to my shop. I'm Brian. This is Builds with Brian. And today I want to talk about CNC work holding, and in particular, vacuum work holding. Now I've done a video in the past using a different type of vacuum table. You can check out the link and see that type of vacuum setup. Today we're talking about using a vacuum system, in particular vacuum pods that use a true vacuum pump. And they pull inches of mercury. And that's just one way of measuring vacuum. So in this video, I'm going to give you an overview of the equipment and tools you need to make your own vacuum pods. They're actually pretty simple to make with your CNC, and actually you don't even need a CNC to make them, but it helps. I'm going to go over an overview of how to make them. I'm going to show you the equipment that you need, in particular the vacuum pump, and supplies you may need in addition to just the pump. And then we're also going to discuss usage. Why is a vacuum pump right for you? There are certain circumstances where it's the ideal solution, and other times you might want to stick with conventional work holding methods. So we're going to begin with the overview of what you need and the vacuum pods themselves, and then I'm going to show you particular use cases of what you can use the vacuum pumps pods for. So anyway, this isn't going to be a terribly comprehensive video in the build of these because they're relatively simple. If I get enough requests, maybe I'll actually make a detailed video of actually how to build these. But let's get into it. Well, first let's talk about why you would want vacuum pods. Well, if you're doing repetitive work, they really shine there. Okay, if you're doing one-off stuff, you might want to stick to just using, conventional methods such as the clamps that hold down onto your table with the T-slots, screwing a piece down, the super glue method. Those all work great. But if you're doing repetitive work, and in this case that I will show you at the end of this video, this particular job that I've got this set up for, I have 70 cases that I have to do multiple operations on. And this greatly speeds up the cycle time of cutting each part. So anyway, that's basically the main feature of using vacuum pods. Not only does it hold extremely secure, but it's fast. All right, so now let me take the camera down and show you exactly what you need equipment-wise to get started with vacuum pods. So we're going to start with basically a whole overview of the system. All right, so obviously my CNC machine with the vacuum pods. Okay, now let's get on to the heart of the system here, which is an actual vacuum pump. And this is I believe it's a Gasket brand. And I got this used. This used to be used by for core drilling, for a core drill machine. And it's a very high mileage pump. It's been used and abused, okay? I've had to rebuild it, and it pulls a vacuum pretty good, but it doesn't reach the high vacuum as it once did. It tops out about 25 inches of mercury. Full mercury is like 29.92 inches of mercury on a vacuum gauge. And you can see this vacuum gauge is even broken. But anyway, I've rebuilt the seals in this, and it's functioning quite well for me. Now, I also want to show you, this is a vacuum pump that I picked up at Harbor Freight to show you guys the differences between these two. Because this pump is actually quite expensive. They can be in the $400 or $500 range if you were to buy this new. All right. This Harbor Freight 2.5 CFM vacuum pump is on sale. It's about 75 bucks. It could be a little bit more if you don't catch it on sale. And it actually pulls a stronger vacuum than this one because it's relatively new. I've had it for about a year. Works great. Now this uses oil, which this one doesn't use oil. So if you are really making money with your machine, if you're putting a lot of work out, I would recommend going with one of these pumps. This is a diaphragm type pump. It's oilless, and it is heavy duty compared to something like this. But this is very affordable, and you have to keep the oil replaced and replenished as it kind of spews out in the mist, which is a disadvantage, but it does work quite well. This will pull a pretty good vacuum, like I said, stronger than that one, and it's affordable. But one of the big advantages of either of these is that over a standard vacuum table like I've detailed in my other video, that uses a shop vac. That'll pull, my shop vac vacuum table will pull about 4 inches of mercury, which is only like 2 psi. These here can pull 24 inches of mercury and like 27, 28 inches of mercury. That's like in the range of like 11 to 14 psi, which gives you much more hold down force. And again, now, one thing I should mention about this is when you get this, you will not have this adapter fitting here to go to the tubing size that you will need for your vacuum pods. You're going to have to get an adapter here, and you can see I just made mine out of copper and compression fittings, and I have a shut-off valve. Another difference between these two is these usually come with a filter. You know, that'll filter out moisture, particulates, and things like that. This comes with no filter, so you don't want to suck, you know, by any chance chips or anything up into your vacuum. You got to keep your area a little bit clean, but this works great. All right, so the next thing I want to show you is this vacuum pump is its power source is plugged into this little outlet box that I put here on my CNC machine. So I feed power to this. It just has a plug on, and I plug it into an outlet. And I have a switch up here. I can control these two outlets separately. And the one is labeled vac. That goes to my vacuum pump. And this one is for, like, say, if I'm using a shop vac to collect chips, so I can turn them on and off independently. All right. So let's continue. Let's follow the chain here. All right. So this hose, which the vacuum is coming through, comes up here and comes into this here. This is a 3-way diverter, or it's a diverter valve, and you can get this online, Amazon. You can get it at McMaster-Carr. But essentially, what it does is it sends whatever you're doing on this in port. It'll either send it to this back port or the upper port. And in my case, I'm using it. The vacuum comes in here. You can see the arrows like the flow of the vacuum. All right. And in this position, the vacuum is being pulled through this open port. I'll explain that a little in depth more later. And if I turn it this way, then what it does is it ducts the vacuum into this manifold where I actually have a gauge set up to read my pressure. And then this vacuum hose here goes back to the back of the machine where I have a manifold. Now, if you're only using one vacuum pod, you don't need a manifold. But if you want to set up multiple vacuum pods, then you need this here manifold. So this is going up to that valve that I just showed you. And all these little valves here, they're all ducted in here, okay? And so you can plug any number of vacuum pods into here. And these are all push-to-connect fittings that are, again, also available off Amazon or McMaster-Carr, as well as, you know, good ball valves. So that's the manifold. So you can see in this current setup, I'm using four ports on the manifold because I'm currently set up using 4 vacuum pods. All right, so that's basically a rundown of the system. All right, now let's talk more about the vacuum pods themselves. All right, so here I have 4 set up. They're clamped down to the table. And of course, obviously see the hose, and they're coming into these fittings. They're all pushed to connect. So you can easily, you know, you push on this. This is tough to do one-handed, guys. But if you push on this, this little black fitting, my left hand isn't as strong as it used to be. Let me put this down. There, so you can see it's just pushed to connect like a shark bite fitting. And, you know, you can plug and unplug these, you know, a lot. They don't seem to wear out. All right, so now let's talk about the construction of the actual vacuum pods. All right, so these are made from PVC plastic. You can actually use a variety of materials. I chose to use PVC because, one, it's a solid plastic. It's impermeable to vacuum itself. But it's basically, I bought a block of PVC, cut it into these sizes, set it on my machine, you know, cut these here shoulders down. I believe I actually did these manually in the drill press, these holes. I just used the CNC to surface the top and cut these here shoulders in. Then in the drill press, I just drilled holes, counter bored them, and they match up with, you know, my T-slots on my table. Okay, once you have that done, you want to bore a hole down here, and I use the Forstner bit, and that goes down, well, most of the way, but it doesn't go all the way through. It goes down to maybe a 1/4 inch from the bottom. And then in turn, you drill, I forget what size it is for 1/4 inch pipe fitting, but you drill in this side and hit this hole. So you have a passage right here. All right, and then you have to tap this hole for 1/4 inch pipe threads. Unless, of course, you use a different type of fitting. You know, you might use something with 1/8 inch pipe threads. Okay, so that's pretty simple. Very simple, actually, and you do not need to use this, you know, to build this with a CNC machine. You can build this conventionally with a table saw. Let me show you here. See, I've actually built one out of MDF, and you can see I've glued 2 pieces of 3/4 inch MDF together, did all the other operations to it, you know, drilled, counterbored, bored this hole down here, and then drilled a hole through here to meet that. And then, now, this is the challenging part with MDF, you know, because you got to tap threads into it. But what I really did was, first thing after I drilled this hole to the correct size, then I put wood glue down in there, and, you know, it helps strengthen the wood fibers. Then I ran the tap through. And then after I ran the tap through, I actually put some silicone sealant on the threads and wound this in, and it seals quite nice. And this is a pretty cheap plastic fitting. These are available also. You can get these at Lowe's or Home Depot. So there you go. This is a fitting for 3/8 inch OD tubing to 1/4 inch male pipe. That's what this is. This is the same thing, just made out of metal, and this is push to connect as well. All right, 1/4 inch pipe threads. Okay, these are a little more, well, actually I can't say they're more expensive. With what Lowe's charges for these things, it's crazy. Another word is you can also get, you know, if you're having a problem routing, if you need to have a tighter system of your hoses here, you can, you know, get 90-degree fittings, and these are also push to connect. All right, the tubing itself, guys, is readily available. And again, this is pretty inexpensive at, say, Lowe's or Home Depot. It's basically polyethylene tubing, 3/8 inch OD, 1/4 inch ID. I mean, it might be like $8 for a 25-foot piece of this. And then you just cut it to length. Okay, so I guess this gives you a good understanding of how simple these are to make. Now, I will say one thing about using MDF. Since it is porous, you have to seal it. So you can see the different color here. I actually painted wood glue over all the edges, the bottom, the sides, everywhere, except for this top area. You know, and what that does is once that glue is set, you can sand it and maybe put another coat on if you want. Or you could use shellac or varnish, but what you need to do is seal these edges because MDF is actually porous. But this works basically the same as that. A lot less expensive to build, readily available material. So, however you want to make yours, there you go. This was actually the first one I ever made, which was, this is just a piece of, I think it was 3/4 inch clear acrylic. And you can see here, I drilled a hole down through there. You might get a better look here. And then it's tapped and it meets up with this hole here. And this has a bigger surface area, and it worked quite well. But it wasn't exactly what I was looking for. I wanted something with a little more thickness, like depth to it. And that's why I made the PVC ones. Okay, so we've gone over the system. We've gone over the vacuum pods themselves. Now let's talk about, you know, what you need for a gasket on top, because that is equally important. So I have found through my experiments that you can use, this is actually drawer liner that you can buy at the big box stores, you know, for like lining a toolbox. This works really good. Only problem is it doesn't have a sticky back. It just comes as it is. You cut it to size. I've got this at a craft store like Michael's or Joann's, wherever. This is just a foam sheet with a sticky back. So you can cut your gasket to the size you need it, and then you can peel it off and stick it on. And that's exactly what these are. This is that foam. Something else that works great is rubber gasket material. And this is also available at Lowe's. I'm sure you can get it plenty of other places as well, but it's called rubber packing sheet. It comes in like usually 6 by 6 inch squares, and you can get it either an 1/8 of an inch thick or a 1/16 of an inch thick. And then you can cut your gaskets, you know, to size using this. And it's pretty inexpensive. Here's 1/16 inch rubber. This works really good. Now, what I can't recommend for this type of vacuum pod is just an O-ring. They work, they seal quite well, but the problem is when you if you just lay this on a flat surface like this one, right here, if you just lay it on there, that will vacuum seal really, really tight. But because this is round, you can actually like apply sideways pressure and that gasket kind of rolls. So you can actually twist this a little bit, it can roll a little bit. I mean, if you have a profile that is not round, I'm sure it would work great, but you can see these are flat. These are not going to roll. So I recommend using this stuff. Now, of course, if you want to make a dedicated fixture using O-rings, one size all the time, then you just want to just route a groove that this would set down in that groove, and then this will not roll on you. Much like some of the professional vacuum table systems that you can buy. They use a material similar to this. So I would stay away from that if you're going to use this flat top design without routing a groove in and using this inexpensive gasket material. All right, so I think we've covered the basics. Maybe I should give you a couple dimensions here. For instance, this vacuum pod, in between the gasket, it's like 2 1/4 by 2 3/4. And that gives you about 5.3 square inches. And this is important to pay attention to the area, because the more area you have, the higher your holding pressure, right? Now, I don't want to get all scientific on you or nothing, but it has to deal with air pressure. Let me show you a quick chart here. Okay. Here's a chart. You can get this offline. Just search for PSI, inches of mercury charts. I'd better put this over here flat. All right. So your gauge most likely for your vacuum pump, if you buy one, is going to read in inches mercury. That's the HG, inches of mercury. Okay, so 0 is basically, you know, no vacuum pressure, all the way up to 29.92 inches vacuum pressure, or inches of mercury. All right, and then that translates over to this column over here on the left, PSI. Okay, so at sea level, the most you can possibly pull is this vacuum pressure, which will give you 14.7 PSI pressure. So depending on the elevation of where you're at, like I'm at about 1,000, 1,100 feet elevation, I max out like around, this doesn't have it on this chart, but about 14 PSI, which is around, you know, between 20 and 29 inches of mercury. So if you live in Denver, for example, which is 5,000 feet above sea level, then your maximum vacuum you can pull, it will be less than that. But trust me, it's more than substantial for what you need. I mean, you're not machining anything on the top of Mount Fuji or anything. So, all right. So you can get a chart like this if you want to see exactly how much PSI you're using based on what your vacuum gauge will read. You see how this vacuum gauge here, this outer ring here, 5, 10, 15, 20, 25, 30, that's your inches of mercury vacuum. Okay. So that's pretty simple. So let me give you an example here. 5.3 inches of area. If I'm pulling 24 inches of mercury, which my older vacuum pump does, I'm getting a little less than 12 PSI. Okay, so 12 PSI pressure times 5 is over 60 pounds of force. This will hold, just one vacuum pod will hold down with. So if you need to scale up these vacuum pods to hold something stronger, you can easily do it. You just make your vacuum fixture bigger, so you have more square area. All right, this is getting really long. So I think we covered everything on all of this. let me set up and show you. Oh, no, we gotta talk about some of the don'ts that you don't want to do. All right, so first, let me show you this working with wood. All right, so I have 4 vacuum pods and they're all set up. Let's turn the vacuum pump on. Okay, and then right now my vacuum is going to open air, so I can't pull a vacuum there. So let's put this here piece of plywood on the jig. Okay, so now we turn this. Sorry, there we go. Okay, sometimes you gotta push down on it a little bit. It's bent. So now it's pulling a vacuum. Okay, and I'm pulling, because this is plywood, it's a little bit porous. I'm pulling about, what, 22 inches of mercury. Boy, that's strong, okay? You can't move this. You cannot move that. Now let's release the pressure. Now, it just vented the pressure off. The pump is still on, you may notice. Let's flip this over, because this other side has like a, it's pre-finished, so it's sealed. Okay, turn the vacuum on. Give us a little push. All right, so now it's reading 24 inches of mercury. So you see the difference there is because this is bare wood and it's a little more porous, and whereas the other side is pre-finished, so it's kind of sealed up. So it works good on wood, guys. All right, let me show you. This is acrylic, and I'm going to just set these acrylic pieces. Has the paper on it. Where's my other one? Okay, so now we have 4 pieces of acrylic. Turn the vacuum on. All right, and we are pulling about 24 inches of mercury. Now, I'm going to show you one of the downsides to these type of vacuum pods. Okay, I'm going to have to put this microphone down here. This is 1/4 inch thick acrylic, and this is going to be tough to see, but there can be a little depression in the middle because the vacuum force is so strong, it'll pull this middle down into that void, and you can have a little gap here. And let's show you this with a piece of aluminum, 1/16 inch aluminum, which will show you that a little more exaggerated, and then I'll explain what I mean by all this. Okay, pull the vacuum. All right, so that's held down. Now you can see this a lot better. You see how it dishes down in the middle? Yeah, that's just the side effect, I mean, to this type of vacuum pod. All right, why is this important? Well, if you were engraving on this surface and you have your Z depth set to a particular height, that's gonna mess you up. All right, if you're just doing holes, through holes, or profile cutting, no problem. But if you need to route down to a specific depth that has to be correct, then this may not be the ideal situation. You may want to use a filler piece in here. You can put a little filler piece in here, or you can build one of them vacuum tables that has all the grooves and that supports the material a little bit better. But the advantage of these is they're very inexpensive and simple to build. So I just thought I'd point that out. All right. So obviously nothing is absolutely perfect. Let me show you. I'm going to have to put this on the tripod, and I'm going to show you what I was talking about, how I'm going to machine these cases and why this is the best solution for me for this project. This is what I'm doing. In these boxes, I have 70 of them that I have to put these 2 holes in. All right. So let me show you how simple this is. Vacuum pump is on. I place this upside down in the fixture against stops. All right, turn the vacuum pressure. Now I'm up to 24 inches of vacuum. In this case, this is too deep for my machine, so I actually have to open it up, and then I run the program. And normally I would have the dust boot on, and I'd be collecting the chips, but in this case, I'm going to put it on. All right, it's done. Vacuum off. Set that down. Grab another part. Repeat the machine. Now you see how fast that was? It just seconds to get the new part in here. That's where this vacuum type pod really shines compared to trying to clamp it down with even toggle clamps or trying to do any other method. So let me know what you think of this video. I hope it helped some of you. I know it was rather long, but it was kind of an in-depth thing. If anyone wants to learn more about vacuum pods, the actual detailed construction, if I get enough requests down in the comments section, maybe I'll make a video showing you exactly how to build this type of vacuum pod. But it is pretty self-explanatory. Thanks for watching.